Is going to be about finding the derivatives of inverse functions. A lot of algebra are going to happen, especially with the beginning of this lesson. So make sure you're taking your time, working through it. This can be, I know it only has 2 learning objectives, but some of them are going to be pretty tough in terms of like the persistence to get through the algebra. So make sure you're following along with how to do this, okay? So there's a lot of information in the textbook if you want to read it about how they proved this idea of getting these formulas. But I'm really going to just be focusing on this right here, all right? Finding the derivative of the inverse function, g of x, is the same as doing 1 over the derivative of the f of x function, but evaluated at the original g of x function, okay? So there's a lot going on here. We also are going to use these formulas, but I don't feel like this will be much of a stretch because we've been working with the power rule for many lessons now. So I think you're going to feel like the power rule, extending it to use with rational exponents, won't really be that big a deal. All right, so let's try one. All right, so we're given the inverse. We're going to use the inverse function theorem to find the derivative of this g of x function. Okay, so again, I'm going to be using that formula. I'm going to copy it down right there, the g prime of x. So g prime of x is equal to 1 over f prime evaluated at g of x. Okay, so just copy that down. We're going to find a lot of stuff. All right, so the first thing I'm going to do is I'm actually going to find the inverse of this g of x function. All right, so if you remember from your days in algebra, the way you want to do this is the first step is to replace the g of x with y. Then my x's and y's are going to switch places. So x equals y plus 2 over y. Now we're going to solve for y. I know there are 2 of them. You're going to see what I'm going to do first. Move over the y to get x times y. Move the y that's with the 2 to the other side. You get xy minus y equals 2. Factor out your y's, x minus 1. And then divide both sides by x minus 1, and you get the inverse. So this right here is the f of x function. Okay? So now again, I'm going to be finding the inverse of finding the derivative of g of x by using this formula up here. So I need to find now the derivative of the f of x function, which I just found. So the derivative, let me kind of view that as like step 1. Here's step 2. The derivative of f of x function is going to be okay, sorry about that. So I'm going to find the derivative of the f of x function, and you'll notice I'm going to be using the quotient rule, all right? So I'm going to do the quotient rule, which is the derivative of the numerator. Nope, I don't want to do that. I want to do this. Let me do this. Let me rewrite it first. Oh, I guess I could have done that. Oh, well, that's fine. I'll just rewrite it first. So I'm going to rewrite it as x minus 1 to the negative first power. Now to find the derivative, I'm going to move that negative 1 to the front, and it's going to multiply to give me negative 2 times x minus 1 to the negative second power. And then because this is the chain rule, I'd be multiplying by the derivative of the inside function, which is x minus 1. But the derivative of x minus 1 is just 1, so it doesn't actually change anything. So my derivative is negative 2 over x minus 1 squared. Okay? Now remember, I'm just right now, all I'm trying to find is this denominator first. Okay, that's all I'm trying to find. So right now I found the derivative. Now I need to find f prime of g of x. So I'm going to plug in where it says x, I'm plugging in g of x, which is x plus 2 over x. Okay, minus 1, all of that squared. All right, I'm going to keep going, get a common denominator. Common denominator is going to be x. That's going to be negative 2 over x plus 2 minus x over x, all of that squared. I'm going to continue on this next slide. All right, so that's going to be negative 2 over, and in my denominator, I'm going to get the x's make 0, so it's 2 over x squared. Keep going. negative 2 over, I'm going to square these things now, 4 over x squared. All right, that can be a little confusing. So I'm going to write that as negative 2 times x squared over 4. So this becomes negative x squared over 2. Now, don't think that's your answer, right? That's not the answer. Ultimately, what I just found, I know there's a lot of algebra, but what I just found is highlighted in teal. So that has to be 1 over. So to 1 over this function, all right, or 1 over this function that's evaluated within the derivative, my g prime of x is going to be 1 over this. So they switch places. So it's going to be negative 2 over x squared. All right, now, I know that you've done this problem for a while now, but just to kind of show you where all this is going or kind of loop it back to stuff we've done in the past, you'll notice to find the derivative of this g of x function, I could have just used the power rule, the quotient rule straight away. So let me do that. Let me prove to you that we found the same thing. So I'm going to do g prime of x is d dx of x plus 2 over x, which is the derivative of the numerator, which is 1, times the denominator, minus the derivative of the denominator times the numerator, all over the denominator squared. So that's going to be x minus 2, all over x squared. X minus x is 0, so that's going to be negative 2 over x squared. So we got the same thing, right? The same thing that we found there. All right, so again, there's a lot going on here in terms of using those formulas, but wanted to loop it back so you could see that we found the same thing. Let's keep going. So we're going to do the same kind of problem here to find the inverse, or excuse me, the derivative of g of x. Okay, so I'm going to use that formula again. I'll copy it down. G prime of x, right? The derivative of g of x is 1 over the derivative of f of x evaluated at our function g of x. So first thing we're going to do is find the inverse of g of x. So y equals the cube root of x, switch x and y, and you get, if you cube both sides, you get y equals x cubed. So my f of x function is x cubed. All right, now, that's kind of like the first step. The next step is to find the derivative of our f of x function. So d dx of x cubed, which is just 3x squared. All right, again, I'm going to find this first, and then I'll do 1 over everything at the end. So I'm going to plug in. So f prime of g of x is 3 times the cube root of x squared. Now, it's been probably 2 years now since you've talked about rational exponents, but you can actually rewrite this cube root of x to the second power. You can rewrite that to be 3 times x to the 2/3 power. So these are going from a radical to be a rational exponent, so a fraction exponent. Remember, that's not the answer. I need to do 1 over that. So 1 over 3x to the 2/3 power. So to simplify this, you'll get 1/3 times x to the negative 2/3 power. Now you'll see later how we can just use the power rule to have done this. I'll show you to the side here. I'll use a different color. So if I had originally written g of x, I'll do it up here, g of x to be x to the 1/3 power, you would do 1/3, this is for the derivative, so power rule, 1/3 times x, and then 1/3 minus 1, right? 1/3 minus 3/3 is going to be negative 2/3. And look at that, that's the answer. So you'll notice that whenever I see this problem, like on the AP exam or an AP question, I'm not going to be using this inverse function theorem, but we're using it to help you understand of how to get to this stuff. All right, so now that we know that, let's kind of do this problem. Again, another lesson with another problem about finding the equation of a tangent line. All right, so the first step is to get our point. Our point is going to be x equals 8. Let's find the y value. So I'm going to plug in 8. All right, you could type this into Desmos, or I know that the way to do this is to do the cube root of 8, right? The denominator is the radicals, or the index of the radicals. So the cube root of 8 is 2. 2 squared is 4, so my point is 8, 4. Find the derivative of y. So that's going to be 2/3 times x, and I'm going to subtract 2/3 minus 1. So 2/3 minus 3/3 is negative 1/3. All right, plug in my 8. So y prime of 8, 2/3 times 8 to the negative 1/3. This can get a little kooky here. Let me give you a moment to think about this. So this is actually going to be times 1/8 to the 1/3 power. All right. Anything to the 1/3 power is essentially just saying find the cube root. There we go. So it's going to be 2/3 times the cube root of 8, which is 2, so times 1/2. So my slope, right, finding the slope here, is going to be 2/6, which reduces to 1/3. All right, so there's my slope. All right, this is my slope. I've got my point ready for point slope form. Y minus y sub 1 equals m times x minus x sub 1. So y minus 4 equals 1/3 times x minus 8. Distribute. You get 1/3 x minus 8/3. Move over the 4 and get 1/3 x. If you add 4, that's going to be 12/3, right? 12 divided by 3 is 4. So negative 8/3 plus 12/3 is plus 4/3. We did it. All right. Let's keep going. Now, there's a long section in the textbook about how to kind of get to these the derivatives of these inverse trig functions. I'm not going to spend my time doing this. This next problem, I'm going to help us figure it out using what we just talked about. But ultimately, I'm going to fall back on the fact that you're going to get this formula sheet when we take the test. So don't stress about like deriving them. Just definitely use these to help you. All right, so let's do that same process. Remember, the formula is g prime of x is equal to 1 over f prime of g of x. Now, I recognize that I just gave you what this is, right? The derivative of the inverse sine function is right there. So I'm going to show you kind of some work to get to it. So the first thing I'm going to do is talk about finding the inverse of the inverse sine function. Well, the inverse of the inverse sine function is actually the sine function. Okay, so that is our f of x. Let's find the derivative of that. You guys know the derivative of the sine of x is cosine of x. So to show my work for finding the derivative of g of x would be 1 over cosine of x. All right, but I'm going to replace that x with my g of x, which is sine to the negative first power of x. Okay, now I'll show you in class on Desmos what this looks like when you graph it, but essentially what we know using that table of formulas there is that this is the same as doing 1 over the square root of 1 minus x squared. All right, so this is going to be what we use going forward. All right, now let's use these. All right, let's use these in the rest of these problems. We're almost there. Keep going. All right, so we're going to apply the chain rule to using this right here. Now it says to use what we just did, but I'm just going to go straight to how I would do this if I saw this on the test in this class or on the AP exam. I'm going to have this formula, so I'm going to do the h prime of x, all right, is equal to, and right, I need to do d dx of sine to the negative first power of 2x cubed. All right, so this is the chain rule. The derivative of the inverse sine is 1 over the square root of 1 minus your argument squared. So 1 over the square root of 1 minus your argument, but look at our argument, it's 2x cubed, and all of that squared. But times, and this is the chain rule, right? Times the derivative of the inside function. And the derivative of this inside function is going to be 6x. All right, 3 times 2 is 6. I'm sorry, 6x squared, my bad. 6x squared. Okay? Now, I can make this look a little nicer. So we have h prime of x equals 6x squared all over square root of 1 minus, and then 2 squared is 4, and x cubed squared is x to the 6th power. So that's it. All right, so that's using those formulas that you'll be given on your formula sheet. Let's try this one. Again, using the formula sheet. So f prime of x is the derivative of the inverse tangent function of x squared. So I'm going to use my inverse tangent derivative of that formula, which says 1 over 1 plus the argument squared. So that's going to be 1 over 1 plus my argument, which is x squared, all of that squared. Okay, times, remember this is the chain rule, times the derivative of x squared, which is 2x. So the derivative of f of x is 2x over 1 plus x to the 4th power. Again, you'll just get good at using these formulas. Okay, so this one, all right, this one is we're going to use the product rule in order to find this, and we have to use the derivative of the inverse sine function. So to find the derivative of h prime of x, I'm going to kind of cut out some steps here. We do the derivative of the first one, which is going to be the derivative of x squared, which is 2x. So 2x times the inverse sine function, plus the derivative of the inverse sine function, which we know from our formula sheet, is 1 over the square root of 1 minus the argument squared. So 1 over the square root of 1 minus the argument squared. In this case, the argument is just x. Good. And then times the original first function, which is x squared. All right, so we'll clean it up a little bit. So 2x times the inverse sine function plus x squared over square root of 1 minus x squared. And that's it. That's our derivative. That's using the product rule. Okay, let's try this one. All right. So we're going to be doing that same thing. You'll notice every lesson we pretty much have another one where it asks us to go from position to velocity or maybe even acceleration. So this one says we have a position function. We want to find the velocity. So I need to find the derivative of my position function. So s prime of t, which is the same as velocity, is going to be d dt. I did it. It's a miracle. d dt of the tangent to the negative first power of 1 over t. This is the inverse tangent derivative, which I go back here. I have 1 over 1 plus the argument squared. All right, I am going to need to use the chain rule. So 1 over 1 plus the argument, right? The argument is 1 over t squared times the derivative of 1 over t. I'll do a little work here to the side. The derivative, d dt of 1 over t. I'm going to do the derivative of t to the negative first power, which is negative 1 times t to the negative second power. Or if I rewrite that as negative 1 over t squared. All right, I'm going to distribute to get negative 1 over t squared times 1 is t squared. Oh, let me do this first before I distribute. Sorry about that. Let me clean this one up. So 1 plus 1 over t squared times negative 1 over t squared. Now I'll distribute. The top times the top is negative 1. Bottom times bottom. 1 times t squared is t squared. 1 over t squared times t squared is 1. So this is the velocity. All right, now we're not done because we need to evaluate this at time of 1. So I'm going to plug in 1 where I see t. So negative 1 over 1 squared plus 1. All right, we have 1 squared plus 1. That's going to be 1 plus 1 is 2. So negative 1/2 units per time. There's our velocity. All right, so hopefully you see how we're kind of just continuing to use our differentiation rules, but now throwing in another couple of curveballs with the derivatives of inverse functions as well as the derivatives of the inverse trig functions. Good luck.